Continuing looking at nitrogen compounds. So nitrogen sits on top of group 5 or 15 in modern notation, has 5 electrons, so you can make negative ion of N3 minus, oxidation number -3, or remove all electrons all the way to +5. Great number of oxidation numbers possible. So now we'll look at compounds nitrogen with oxygen. Compound with oxidation number +1 is dinitrogen oxide, N2O, nitrogen, nitrogen, oxygen, bond here. It's linear molecule. It can be made by decomposition of ammonium nitrate. Nitric oxide, NO, very stable molecule with very short bond. It's radical. Next, with +3, dinitrogen trioxide, anhydride of nitrous acid, is such a symmetric molecule. One more radical molecule is NO2, nitrogen dioxide. Because there is one unpaired electron here, it easily makes nitrogen-nitrogen bond, same as here, to make dinitrogen tetroxide molecule. These two exist at equilibrium. Now it is possible to make dinitrogen pentoxide molecule N2O5. Nitrogen oxides are famous because they can be made at spark conditions. So when oxygen reacts with nitrogen, oxygen of air with nitrogen of air at spark, they make nitrogen oxide. Oh, well, these conditions exist on internal combustion engine. So always when we have gasoline engine, we have some admixture of nitrogen oxides. And they need to be removed along with carbon monoxide, and for doing that we have catalytic converters in exhaust pipe. So carbon monoxide and unburned hydrocarbons react with oxygen to make CO2 and water, and nitrogen oxide are the same. These are mainly based on ruthenium and a couple of other noble metal compounds. Nitrogen monoxide and nitrogen dioxide on catalytic converter decomposes, making nitrogen molecule and oxygen molecule. Nitrogen monoxide easily reacts with air to make NO2, so NO plus O2, NO2. NO2 converts to colorless nitrogen tetroxide at low temperature and reverts to NO2 at higher temperatures. Very common rule: when you increase temperature, dissociation occurs. So N2O4, when you heat it, decomposes to NO2. N2O4 is colorless, and then color becoming deeper because you have deeply colored NO2. Dinitrogen pentoxide molecule, its oxidation number +5, can be made from nitric acid when you apply P4O10 to it. P4O10 has very high affinity to water, making H3PO4, so it removes water from nitric acid, leaving N2O5 molecule. oxo ions of nitrogen. You can have N2O2 2 minus, quite unusual. Now very common is nitrite ion, NO2 minus. It's weak base and oxidizing agent and reducing agent. You can oxidize it to nitrate, or you can reduce it to nitrogen. With plus 3 in acidic solution, you can make nitrosonium or nitrosyl cation NO+, which is strong oxidizing agent, and it can serve as a ligand as well. Next, with the oxidation number 5, you have nitrate ion. Nitric acid is very strong acid, so there is practically no basic properties of nitrate. Still, it's oxidizing agent. In very acidic solution, you have positive ion, NO2+. It's linear. And again, it's oxidizing agent and nitrating agent. So when you have a mixture of sulfuric acid and nitric acid, a nitric acid is in form of NO2+ to some extent. If you'll have NO2+ and NO3-, you can make a salt which will have composition of N2O5, so it will be dinitrogen pentoxide. This is solid form on N2O5 molecule. Nitrites and nitrous acid. Nitrite ion is banned because it's lone pair here, and the same is true for nitrous acid that has double bond, single bond. Two bonds are identical in nitrite but not in nitrous acid, and there is lone pair here. Nitrous acid can be made directly by reaction of N2O3 with water, making HNO2. In turn, N2O3 are made by reaction of NO with NO2, making N2O3. In absence of water, it's beautiful blue liquid because it has such an unusual structure. N2O3 can react with sodium hydroxide to make sodium nitrite and water. Alternatively, you can make sodium nitrite by decomposition of sodium nitrate, and oxygen will be released. Most of other metal nitrates, when heated, will make oxide and nitrogen and oxygen. Nitrates are perhaps most common compounds of nitrogen, other than organic. Of them, sodium nitrate is mined in Chile and is known as Chilean saltpeter. Potassium nitrate is known for hundreds of years as saltpeter, can be manufactured easily in any agricultural environment. Just funny procedure manufacture of saltpeter by Joseph LeConte. At times of civil war, they needed lots of potassium nitrate to make powder. So describe process when horse urine was collected in sand pit under stable. And then after some period, urine was oxidated to nitrate. was dug out, leached for nitrates, then were converted to potassium nitrate using potassium carbonate, which is potash. Very important compound is ammonium nitrate that is used as fertilizer. Another use is its explosive. Itself, it's colorless salt, but when people do not know how to use it, it can explode with very violent force. This year accident in Beirut that resulted in destruction of a large part of Beirut port and large part of city. Ammonium nitrate, among others, was used by Takata Corporation as a cheap airbag inflator instead of tetrazole, and you may heard that plenty of airbags are recalled during recent years because they needed to be replaced. Ammonium nitrate can attract some moisture and your bag will not work. So, as a summary, we can look at possible reaction of nitrogen. So you're making ammonia. From ammonia you can make halogenides easily. You can make ammonium salts. You can oxidize ammonia to nitrogen oxide, from there to NO2 and 2O3, and making N2O4 alternatively, or making nitric acid. You can also go and make nitrites.